Hello, everyone. Mic's working. Okay, good deal. So we're going to talk a little bit about MPE today, and a little bit about AI today. Hopefully, I can provide you a couple of good nuggets of information while I try to cram a lot of detail into 20 minutes. So let's get started pretty quickly. So about me, just real quick, I've been in the business for about 35 years, worked on a lot of different things, and I'm an adjunct professor at Baylor University. Been working on AI-related things probably close to 20 years. So I've got a couple of pet peeves and some nuggets hopefully I can share with you. I work for a company called EverFox, and we're at booth 301. I'll just put that up front. If you guys have questions about it or you want to debate about any of the stuff that I might say, please come on by. All right, let's get started. So in the audience, many of you probably either know what MPE is or you don't, but the ones that do know that it's a very complex web of bilateral agreements and communications interfaces and all kinds of things that complicate the environment of building architectures when you have all of those problems. The other component of this briefing is about agile combat employment, which is literally about being proactive and reactive very rapidly in complex environments where you have to move forces and you have a lot of logistics and all those things that we're supposedly really good at. The whole objective behind this, right, is to fight faster together, make better decisions over the long haul, right, and shrink that kill chain. And so there's a couple of things that we do and that we're in the middle of that I'm going to talk to you a little bit about today that hopefully helps shed some light on some ways to build these environments a little bit better. So this is where we are now. Obviously, we have really good sensors, but we can be more efficient. And if you're talking about kill chains now in days and hours, maybe minutes, depending on what's going on in the ad hoc environments, what we really want to get to is this, right? And this is what we're really shooting for, is we're building mesh comms architectures. We're building, we got AI on all the various different platforms is where they like to go. And when you have this kind of added complexity, there's a lot of things we have to think about relative to AI itself. And we're going to talk to you a little bit about that. So we can get down to the kill chain shrinkage down to minutes and seconds, or maybe even having it predictive. Not just seconds, but predictive. So a priori, it is already figured out before it even happens. So how do we do that? So what is AI and why do we actually care? Sorry about this thing. So first off, what I like to always tell people is AI is software. This is some fundamental things that I think we have a real problem with in the industry. It suffers from all the same problems that software suffers from. It's got versioning problems. You can have insider risk related issues with these platforms. It is just software, okay? And it's about automation, right? A much higher level of automation. So what do you get when you get higher automation at that scale? You can fail faster just as well. So how do you stop some of that? So let me just ask a question. How many of you are afraid of AI in general? Show of hands, or are concerned? No concerns? No fear? We got one. Okay, we got one in the back. All right. Well, the point is, part of the problem is that this is what, when we're talking about implementing the solution sets, right? The one thing that we really have to remember, and there can be a lot of debate about this. I've had a lot of debates and arguments about this exact topic, but AI remembers. It is a collector and a rememberer. It is not something that learns. It's a huge fallacy, and our perception of some of the systems that we put out and that we're going to end up putting out there, if we believe that that system is more intelligent than it actually is, there are lives at stake that will be the cost of making that mistake of that perception. And so my whole point is when you understand fundamentally what's happening under the covers, learning is about applying information you remembered. Yes, remembering is a function of of getting really good contextual information, but it is not how you apply the information. There's a big difference, and we can debate that, and you can come by booth 301 and we can talk about that if there's any questions about that. However, right, AI improves decisions. When we know our data and we can build the bounding box correctly, right, we can shrink that timeline from days and from minutes down to seconds, or even prediction, or even anticipation, knowing it beforehand, right? We can reduce bias and errors, but all of that is predicated on us knowing our data better and knowing what our systems can actually do. And so then the next question usually I get asked is, well, how in the heck do we do that? How do you measure that? Well, there's ways to measure risk. We just don't do it. We measure uncertainty, we measure probabilistically how something's going to happen, but we don't actually measure the systems in terms of how much risk it's going to be using that versus something else. For example, now, in order to support, decision dominance, which we think AI can do, we're going to have to mitigate those threats by understanding and doing some of that risk mitigation that way. So why is AI security so much more complex? Well, when you think about the increased volume and speed of data ingestion we're doing, and you're doing it at the edge in every platform, think of the Tesla environments, right? Tesla's doing the same thing. It should be easy, right? It's not. And that's because the lack of data flow enforcement, the lack of data integrity in that architecture, which is a lot more critical in our environment than it is in a Tesla environment, and the increase of interconnectivity, the IoT content, every soldier is a sensor type of a platform, that significantly adds to the complexity. So if you have increasingly higher levels of automation, what the autonomic information continuum tells us is, as you move across that spectrum from manual to highly automated or autonomous or even self-evolving, if you think about how Hollywood thinks, right? Your systems get more complex, the systems get more ambiguous, and you trust them less. So the forcing function is you must measure that trust in some way, shape, or form. So many of you are probably familiar with this triad. The one that we're going to focus on is the data integrity piece, which is the part that we actually do as a company. And that's making sure that every bit and byte is allowed to travel from point A to point B, which is a very different thing than encrypting something, which is a confidentiality problem. Okay, AI poisoning. Let's talk a little bit about that at a very high level. We know about data tampering, but some of the things we don't think about when we think about data tampering is every one of those engines that we use out there, whether it's Claude or BERT or ChatGPT, any of those LLMs that a lot of people are using, that data is already tampered prior to you even using the tool. If you think about what that's trained on, a large portion of them, the initial data sets that they used was Wikipedia. No one controls that content, but that's what that's trained on. The other things that they train on is every prompt that a human makes is additional data that goes into that environment that it becomes trained on. All of those things can be data poisoning events if we're not careful. So if you're not taking that content and you're removing that ability for it to learn, from Wikipedia and instead learn about the data in your environment, it's critical that you figure out a way to do that. Now, how to do that, we can talk about later. So you can corrupt models that way, and then those models become shared across your enterprise. It can create a lot of problems. So on top of all that, NSA still says you have to have CDSs in all of your architecture. So how do you do that? And that's what we're going to talk a little bit about here, because we're going to talk a little bit about what's the objective. So in a true mission partner environment, and we're trying to do agile employment of capabilities, every single platform in your OODA loop, right, that's performing your OODA loop, every sensor is also an effector. So the question is, how do you take that type of system, which is usually done over not the same network, right? Multiple different networks. How do you make this happen? Or this is the kind of the end state we're trying to look for. These are your Teslas, right? That's your mothership collecting all the content as well. But these things are all learning all on their own, and they're sharing data with each other as they learn, because in some DDIL environments, they may not always be able to send their data back. So to prevent data poisoning, there's a couple of things you can do, right? You can do deep content filtering, you can do really deep policy engine enforcement, and you can log and audit everything. And there's ways to do that in a manner that enables you to still handle it in a tactical environment. And those are some of the things that we're currently working on, and at various different hardware levels down to the very tactical edge from the enterprise. So how are we doing on time? I've been going pretty fast. All right. So there's a couple of different ways to implement the solution set in order to get no-kidding cross-domain solutions embedded into these mission partner environments, where you can have essentially no zero-day web browsing from an access perspective, and non-attributed web browsing, for example, to be able to browse down from high into the unclass and be secure that you're doing it correctly, and move data between those environments with a level of security such that you don't have those data poisoning risks. So this is going to be a very high level solution set that I'm going to show you here, where that is actually also describing how one theater of operations is actually trying to implement, but it's the same solution set that's required in order to build these environments in a secure manner. So if you think of the outer boundary there as the US 5i controlled environment, which it has to be in order to make those architectures function, this middle environment becomes your complete hardware stack and your virtualization environment, so you can dynamically virtualize the capability set to get agile employment of capability. So essentially all of your apps, all of your hardware, your entire rack of capability set, basically what your DMZ does, right? And many of you who are network folks in here probably understand, those DMZs, we've been building those for years to basically protect those type of environments, to make them highly secure. Whether we considered it Centrix or whether we considered Afghan Mission Network, whatever those networks were, we controlled those environments and all the data that was going inside of them. The difference is you're now building it up, whether it's in a cloud environment or it's just an on-prem virtualized environment, whatever that environment is, that's what's creating your web desktop environments that allow that ability to share your common operating picture with coalition forces. And that's essentially what we're talking about. And then also your AI platforms are just your other hardware stack and software applications that are running in that environment that can do the correlation and fusion across all those data sets to be able to get the common operating picture for whatever mission that is. Mission A with 2 countries, mission 2 with another 2 countries, etc. So the way that happens on the US side is we put hardsec access, cross-domain access, and transfer solution into that architecture in order to enable that. But it's the reason why these are here is because they also add as a protective filter that brings your classification level down to a moderate when you're working through your accreditation. And then you add those hardsec access solutions that are accredited as well, and the cross-domain solutions that exist today in order for those separate countries to push that content into that same collaborative environment. Now, this is very high level, and there's a whole bunch of things missing off this picture. I have a very detailed one that I removed from this deck because there's no way to talk through the level of detail that's required to do all those pieces. But that's essentially, in a nutshell, what we're talking about. So I think we have a minute or two for a couple of questions. If you guys want to throw darts, you're welcome to. And if not, come by booth 301 and we can talk about it some more. So, yes, sir.
I had a question about your. Yes, I had a question about. It looked like you were on a higher enclave and you were surfing through the web on a lower enclave to go to through your cross-domain solution. What I'm curious about is on a lower domain internet type situation, I might run into a poisoned page, something that has malware that I can pull in. How are you protecting the users against pulling something like that back into the higher echelon?
So, well, two pieces there. First is you have to have the right solution in place to do that. And there are access solutions out there that allow you to browse down. So browsing down is not transferring up. Two different parts of the equation, right? Browsing down allows you to get to, with these types of solutions, you can get to a no 0-day web browse. So you can browse down from high, whether you're looking at unclassed imagery or whatever it is you need to see, right? Those abilities exist. When you push the data back up, to be really honest with you, it's not any different than the way we do it today, right? We work with many coalition partners today and move data from their environment into ours, right? So there are ways to do that, and we have solution sets that actually accomplish that feat. So how do you do that in if you think about it when you're on a web desktop environment? So let's say there's a file folder, right? That file folder and that web desktop is in an environment that's fully controlled. That cross-domain solution you're clicking on a website outside of it from here. And what happens is that if you put the right infrastructure in place, you can move that file through that solution, put it into that box in your web desktop if you engineer it correctly. And that's essentially how you need a couple of different solutions to make that happen. And that's very oversimplified, by the way. Any other last questions? All right. Come by and debate with me. Have a good day. Thank you.